There is a message sitting on a server right now with your name on it, and that server cannot give it to you. Your app is open, the chat screen is right there. The server has the message and it knows exactly who it is for, and it has no way to reach you. Not slow, not expensive, no way at all. And this is not some corner case, right? A notification, a live score, an AI answer coming out word by word, a payment going through, same problem every single time. And the strange part is this, none of it is the server reaching you. Every single one of those things starts with your browser reaching out first and then holding that path open. So, why? Why can't the server just call you? So, there are two doors here, and the thing is, both of them are shut for completely different reasons. Door 1 is the conversation you already had. HTTP, the language your browser and a server speak, is request and response. You ask, it answers, and that exchange is finished. There is no leftover channel for the server to drop something else down later. Okay, fair enough. So, why does the server not just open a new connection to you? And if you think about it properly, that is door 2. And this is the one most explanations skip. It is not really about addresses, which is how people usually explain it. It is that your browser is not a server. A server at high level is a program sitting there with a door open, waiting for connections to arrive. That is what makes it a server. Your browser does not do that. The JavaScript on a web page is simply not allowed to open a door and let strangers on the internet connect to it. It can reach out, it cannot sit and accept. So, even with a perfect route to your phone, there is nobody on the other side to hand the connection to. And then, on top of that, there is a firewall in the way. Your home router, your office network, your mobile carrier, all of them drop anything arriving uninvited. And that is true on the newer IPv6 addressing as well. On most home networks, there is NAT doing it, network address translation, where a lot of devices share one public address. So the router only remembers connections that went out. And notice the order because it matters. The firewall you can technically switch off. The missing door you cannot. That one is just what a browser is. So both doors are shut, and that leaves exactly one way in. A line you ran out yourself. Every real time system in the world is one answer to one question: who keeps a line open and how? And at high level, there are only three moves. You can ask again and again, you can hold a line open, or you can flip it and stop being a client altogether. So, move one, ask. The simplest thing you can do, just ask again. Our chat app sends a request every 5 seconds. Any new messages? No. 5 seconds later, any new messages? No. Any new messages? Yes, here you go. And that is called polling. And honestly, polling is not a bad thing at all. It is plain HTTP. It works with everything you already have. And a lot of production runs on it very happily. But remember our message from the start? It landed just after we asked, so it sits there for nearly the full 5 seconds. And let us put numbers on it. Say 10,000 people have the app open, polling every 5 seconds, that is 2,000 requests a second hitting you. And the average person waits 2.5 seconds. That does not feel live, so you tighten it to once a second. The wait drops to half a second. Good. And your traffic goes to 10,000 requests a second, almost all of them coming back empty. And the request is not free. Headers, cookies, authentication, and all. For a logged in user, easily 500 to 900 bytes before a single useful character. So you are spending that 10,000 times a second to be told nothing. You are paying full price for a no. So, people did something clever here, and I think this one is the hinge for the whole video. It is called long polling, and the idea is tiny. When the request comes in and there is nothing to say, do not answer, just hold it. Keep the request open, do not send the response and wait. The moment something happens, answer right then. And if nothing happens for let's say 30 seconds, tune to stay under whatever the proxies in between allow, answer with nothing anyway, and the client immediately asks again. So the delay is gone, and the empty answers do not disappear completely, but they drop from every 1 second to one every 30. But look at what you actually did there. Those 10,000 requests a second did not disappear. They turned into 10,000 requests just sitting there, held open, each one occupying a connection on your server and on some older setups, a whole thread. You did not remove the cost, you traded it. Request churn for connection state. Hold that thought because we are going to get the bill for it shortly. First, one more obvious question. If you are already holding the request open, then why are we ending the response at all? And that question is the whole idea behind server sent events. Long polling holds the request open, sends one answer, and closes. Server sent events holds it open and just never closes. The client makes one normal request, the server starts replying, and the reply never ends. A bit of text, wait, more text, wait. The browser reads each piece the moment it arrives. One response staying open, dripping out events for as long as you want. That is the entire mechanism. And mechanically, it is very simple, which is the part I like. The server sets one header saying the content type is text slash event stream. The signal for this is a stream, do not wait for the end. Then it writes a line starting with data and a blank line to end that event. On the browser side, there is a built in thing called event source. Point it at a URL and you get an event every time the server writes one. No library. And because underneath it is plain HTTP, it goes through the same load balancer and the same authentication as everything else. One catch, the built-in event source will not let you attach an authorization header. So same origin apps usually let the token write a cookie. And there is one thing built in that people do not talk about enough: connection drop, right? A phone moves from Wi Fi to mobile data. With servers and event, the browser reconnects by itself. You write nothing. And better, the server can put an ID on each event. And when the browser reconnects, it sends back the last ID it saw. So, carrying on from that point becomes a lookup on your side. But two honest catches, and the second one will actually hurt you. The replay buffer is still your code, nothing is stored for you, and the browser only auto reconnects on a network drop. If your server answers with anything other than a 200 or the content type is not text slash event stream, it gives up permanently. So, one bad deploy or a proxy handing back an error page, and the stream is just dead silently. Now, the real limitation. Server sent events is one direction only, server to client. The client cannot send anything back up that line. And this is where people jump to the wrong conclusion. So let me be clear: a one way stream does not mean a one way app. Your browser can still make completely ordinary requests at the same time, right alongside it. For example, our chat messages arrive instantly down the stream, and when you type one, it goes up as a normal request, exactly like everything else on that site. And honestly, when updates mostly flow down and the user only acts occasionally, that combination is usually the simplest thing that works. Most people have just never heard of it. So, the bill. And the thing is, almost nobody says this part out loud. This is not a WebSocket problem, it is a holding problem. Everything I'm about to describe is already true of the server sent events we just built. Think about it properly. Let us say 10,000 connections that live for hours, each one sitting on one specific machine, and we spent a whole video on why servers should be interchangeable. Any request to any box, restart freely. Holding breaks that. The connection is bound to the gateway that accepted it, and that is not a setting you turned on. It is just that what a live connection is. So, a deploy is not quite anymore. They can all reconnect somewhere else afterwards. That part is fine. But you just dropped everybody who was on that box. Compare it with polling, where a restart costs one failed request and there is nothing to repair. And there is a second one that surprises people. A user connected to Gateway 1 sends a message to a user connected to Gateway 3. Gateway 1 does not know Gateway 3 exists, it only knows the connections sitting on itself. So, the message just does not arrive. And the fix is just a shared channel behind all of them, usually something like Redis. Every gateway publishes what it receives, every gateway listens, and each one delivers to its own sockets. That is PubSub, publish and subscribe. And notice what is genuinely new here. A polling app also needs shared storage, of course, but it just reads the current state whenever it asks. A held connection fleet has to actively route each new event to whichever gateway happens to be holding that person right now. That routing problem is the new thing you bought. And this gives you the two numbers you actually size the system on, which I think is the part interviews are really asking about. 1. How many connections? Because that decides how many gateway boxes you need and how much memory they hold. And 2. How many messages a second times how many people each one goes to. Because that is what sizes the pub sub and your outgoing bandwidth. And they are completely independent. 10,000 quiet connections is a small machine. 10,000 connections where every message fans out to 50 people is a very different one. Okay, so we have a stream coming down, ordinary requests going up, and we have paid the holding bill. So, what is left for WebSockets? It is this: when the client is sending constantly, a cursor moving in a shared document, a player moving in a game, someone drawing on a shared board, each one of those as a separate request means a fresh set of header, a fresh round trip every few milliseconds. And that is where the ordinary request half stops being good enough. So, WebSockets do something different altogether. What if the connection stopped being HTTP? And that is literally what happens. In the common handshake, your browser sends what looks like a normal request, but with a few extra headers on it. The two that matter are upgrade, WebSocket, and connection upgrade. And if the server agrees, it does not reply 200 OK, it replies 101 switching protocols. And the spec is blunt about what that means. A change in the application protocol being used on this connection. Same connection. A moment ago, it was speaking HTTP. Now, it is speaking something else entirely. And both sides can send whenever they want. No request, no response, no taking turns. A two-way pipe. And once it is open, a small message is a few bytes of framing rather than a whole fresh HTTP request. For something firing every few milliseconds, that adds up fast. But the thing is, be honest about what you are buying. The connection bill you already paid with the stream. What WebSockets add is traffic both ways and two costs on top. After that 101, your messages are not ordinary request anymore. Proxies will usually carry the connection fine, but the per request machinery you rely on, the middleware, the authentication, the logging, does not automatically run on each message. And servers and events gave you an event format for free. Here, you invent your own and version it yourself. So, worth it when both sides genuinely talk constantly, not worth it because it sounds more modern. Okay, so every option so far had the same shape. The client runs a line out and holds it open. And that is only because of where we started. You have no door, so you have to be the one reaching out. But now, change one thing. The thing that needs telling is not a browser at all, it is your server. Our chat app takes payments, and the backend needs to know the moment one succeeds over at the payment provider. And your backend, unlike a phone, is a server. It is already sitting there with a door open. And that changes everything because now you can do the one thing a browser never can. You hand them a URL and say, when it happens, call me. That is a webhook. Nothing held open, nothing streaming. Their server just makes an ordinary request to your URL when the event happens. And notice what actually happened here. You did not find a cleverer way to be client. You stopped being a client. For that one request, you are the server and they are the client. That is the flip. And it is the only place in this whole video where a server genuinely reaches out. Now, a webhook is only a HTTP call to you. So, what happens when your server is down when they call? That is not a property of webhooks at all. It is whatever that provider decided, and the spread is genuinely wild. Stripe keeps retrying for up to 3 days. GitHub does not automatically retry at all. If your endpoint is down or takes more than 10 seconds to answer, that delivery is just marked failed. And recovering, it is on you. So read the provider's contract. It is not the same twice. And there is a consequence people miss. If a provider retries, then the promise is that the event gets through, not that it gets through only once. So, at any real volume, you should expect the same event to land twice. Build as if it will. Store the event ID, and if you have seen it, do nothing. This is the idempotency idea from the retries video. And here, it is not a nice to have, it is the thing holding the integration up. One more, because it is easy to get wrong. Your URL is public. Anyone who finds it can send you a fake event. So the provider signs every delivery and you check that signature before you trust anything. And many of them, Stripe included, sign the raw body. So if your framework parses it into JSON first, the check fails. That one catches everybody once. And the shape you want overall is verify the signature, put the event somewhere durable, reply 200 straight away, and do the actual work afterwards. If you process inline and go slow, they time out. And now you are being retried for something you were handling perfectly fine. And one last thing, because it ties the whole video together. Why can a webhook never target a browser? Same reason as everything else. There is no door to knock on. So, how do notifications reach your phone with the app closed? Your phone keeps a long lived line open to Apple or to Google, and everybody's notification come down that shade line. And if you are thinking, but websites send me notifications too, same trick, one more hop. Even push is still your device holding a line open. So ask, hold, flip. Ask is polling, request again and again, and pay in delay and empty request. Hold is a line kept open, and whichever way it points, you pay the same bill. Connections bound to one box, and a shared channel behind the fleet. And flip is webhooks. You stop being a client, hand them a URL, and they call you. Servers only. And here is how I would choose in order. First one that matches wins. Is the receiver another server with a reachable address? Webhook. And none of the rest applies. Is a bit of delay acceptable? Then just poll. Still the right answer far more often than people admit. Does the browser need a constant stream coming down with only occasional requests going up? Servers and events. Does the same connection need constant traffic both ways? Now it is WebSockets. And you are taking the holding bill on purpose. And if a held connection cannot survive, the network in between, long polling is the fallback. And one thing before we close, because it is the mistake I see most often after people learn all this, everything we just did is about how an update travels. None of it, not polling, not the stream, not WebSockets, decides whether that update is stored or retried or even delivered at all if the user was offline. A chat app still needs the user messages in a database and still needs to work out what you missed while you were away. The transport is one layer, durability is a completely separate one, and no choice on this list gives it to you for free. And that is the whole thing. A server cannot start a fresh connection into your browser. So every real time feature you've ever built is just a decision about which line the client opens, how long it stays open, and who is allowed to talk through it. Once you see it that way, you are not choosing between a list of technologies anymore. You are answering four questions in order. See you in the next one.